In this problem, we're looking at P of t is some point on the unit circle, and that satisfies our rectangular coordinates of 3/5 and 4/5. We are trying to find the following translations. Taking that angle t and adding pi radians, taking the angle t and subtracting off pi radians, taking the opposite of t, and then the opposite of t take away pi radians. In order to look at this problem, let's draw the unit circle. We would recognize that we have the point 3/5, 4/5, which is the cosine of t, sine of t. Since both are positive, it implies that we are in the first quadrant. If we took our value of t radians and we rotated it pi units, or 180 degrees, we would have the terminal side lie in quadrant 3, and in quadrant 3, the sine and cosine are negative, therefore it should represent the point negative 3/5, negative 4/5. If we would look at taking our angle t, and instead of adding pi, we are subtracting pi or subtracting 180, we will recognize that we will also end up in the third quadrant, meaning that piece of our t radians minus pi gives us the same value, negative 3/5, negative 4/5. Finally, we are going to look at our last 2 points. P of the opposite of t, that would say that we took this quadrant 1 angle of t radians and rotated it in the opposite directions t radians, giving us a quadrant 4 angle. So the point representing the opposite of t would have a positive x coordinate and a negative y coordinate. In other words, cosine would be positive and sine would be negative. Finally, we're going to take our point at the opposite of t and then subtract off pi more, or rotate it 180 degrees more, giving us the point in quadrant 2. In quadrant 2, we know that our y-coordinate is positive and our x-coordinate is negative. Therefore, we get the coordinate negative 3/5, positive 4/5.